Okay, this is AP acid-base equilibrium free response questions. These are the essay questions, which means you are going to be explaining concepts rather than doing calculations. I truly believe that in this year of 2020, during the coronavirus pandemic, where we are doing at-home tests, you will be having to write explanations more, which I think is really important. And there's lots of ideas that are bound up in questions like this. And so you would expect, this was all total an 8-point question. And so there's lots to say here and lots to observe. So let's get to it. Oxyacids such as those above contain an atom bonded to one or more oxygen atoms, and one or more oxygen atoms may also be bonded to a hydrogen. Okay, first off, we need to revisit, and if we didn't, you need to get this picture about what these oxyacids look like. And we'll go with chlorine. We'll do HClO3. So chlorine, this is going to look like this. And no, we have not reviewed yet Lewis structures, but you will remember that we have these rule breakers in the third row and above. You can have more than an octet, so you can hold more electrons. So chlorine is in the third level, and it can hold more than 8 electrons, so it's not a violation of, it's a violator, but it's a valid structure. Okay, so what's important here to note is that the hydrogen that is going to be released is always going to be attached to an oxygen. Okay, this hydrogen is attached to an oxygen, never to the central atom in an oxyacid. Okay, and so this is talking about, so when we look at these, that's really important to understand. Okay, so it says discuss the factors that are often used to predict the strengths of an oxyacid, those listed above. Okay, so what is a strong acid? A strong acid is one that dissociates completely. So the percent of dissociation is what determines the strength of the acid. So what's going to determine what percent of this compound is going to allow this bond to break. Okay. All right, so that's just general. All right, so now let's go look and see what they gave us. All right, so H2SO4, SO3, and that's a weak acid, right? HSO3, this is the same one. This is what we call a polyprotic, and it's lost one of its hydrogens. And then, so that's a weak acid. This is the super strong, the strongest of the strong, perchloric acid, and this is HCl. This is HClO3. So same central atom. So we're all, and then boron. So what we're going to be doing is we're going to be looking to see what the differences are. And one of those big differences is this central atom. Okay, so what do we know about a central atom and what makes it the central atom? So we're going to draw a Lewis structure. We put the least electronegative central atom in the middle, other than hydrogen, which can never, ever be the central atom because it only makes one bond. And so chlorine is just less slightly electronegative than oxygen, so it's going to be your central atom. Okay, now what we're going to compare is the central atoms, so chlorine versus sulfur versus boron. And we'll remember on the periodic table we have boron, then nitrogen, oxygen. Oh no, I forgot carbon. Carbon, boron, carbon, oxygen, and then fluorine, and here's sulfur, and here's chlorine. Okay, so what do we know about electronegativity? That is the attraction for the shared pair of electrons. Oxygen is very electronegative. Chlorine is very electronegative. And so if we remember about polar molecules, the more electronegative has a strong pull on those electrons, has a stronger dipole, so it's going to pull these electrons toward itself. As it pulls these electrons toward itself, it's polarizing, basically, this bond and weakening it. And so the more negatives you put over here, the more polarized it is, the weaker this bond. And so the faster it's, the more, not faster, that's not what it's about, the more easily it breaks. It's about less energy. The less energy it takes to break this bond. And so there are a couple of things at play here. So we've got different central atoms. So central atoms are different. So I'm just kind of making a little thing. So we got central atoms are different, and we have different numbers of electrons. Oxygens, even on the same central atom. And then we have this little joker right here with the charge. It's a poly that's already lost one of its hydrogens. And so we've got a charged acid versus its neutral, the neutral acid. So we got three aspects to cover here because they gave us three different things. And so typically nowadays, you would have a question be more structured and more specific. This is just kind of wide open, and so you had to pick through all these. That was back in the day in 1986. And so today the questions are more structured. So they would give you a little more guidance. But so we have three things that we're going to need to talk about. So I think I'll make sure I clarified. So the more electronegative your central atom, the stronger this pull of the electrons toward itself, the weaker this bond. So the central atom being different. So we could write that as saying the stronger, the more electronegative, we'll just address this now, the more electronegative the central atom, the stronger the acid, since the OH bond is more polarized, i.e. weaker. That's not i.e. Weakening the OH bond, causing more H plus to be formed. Therefore, stronger acid. Okay, I just said polarizing, weakening this bond, causing more, and I should have inserted something here about requires less energy to break the OH bond. Okay, all right, so that addresses the first sort of thing we have here. Secondly, the difference in the numbers of electrons, of oxygens with the same central atom. So, in general, the trend is, but a trend is never ever an explanation, But in general, the more oxygens bonded to the central atom, the stronger the acid. Since that's the trend, here's the real answer. Since adding oxygen atoms to one side, that's atoms, to one side of the molecule now we need to say it by degrees. So since adding increases the polarization of the OH bond, weakening it. Boy, that's ugly. Thus, less energy is required to remove the hydrogen. Therefore, more hydrogen dissociation. Therefore, stronger acid. Let's see if that makes sense. In general, 1, the more oxygens bonded to the central atom, the stronger the acid. Since adding oxygen atoms to one side of the molecule, I need to say this, since or that could be because or whatever. As oxygen atoms are added, but that means like the more you have, the more it happens. As they are added to one side of the molecule, we should flip this around. Polarization of the H bond increases, of the OH bond increases, weakening it. Okay, I hope that makes sense. And then the third aspect that we noticed up here was the charged acid. Okay, so remember how we talked about the only the first hydrogen ion contributes to the pH? Because the second one is so, there's so little of the second or third hydrogen ion that is dissociated. So the third point here is to say that as hydrogen ions are lost from neutral acids, the strength of the acid decreases since removing a hydrogen from a negatively charged ion requires, it's all about energy, it requires more energy than removing a hydrogen from an uncharged or a neutral acid. Okay, you notice how we talked about energy, energy, energy. So this bond is going to be broken. That's energy input. The more energy it takes that you have to put into it, the less it's going to happen. So, all right. So we've talked about, it says discuss the factors. So what factors? The electronegativity of the central atom, the more oxygens that are bonded to the central atom, and neutral versus charged atoms. Okay. Or ions, acids. Okay. So the second one says arrange the examples above in orders of increasing acid strength. Okay, so B. So you want to start weak, make yourself a timeline. Weak versus strong. They said increasing, right? Increasing, yes. Okay, so we said, so we can do this up here and then copy it down at the bottom. All right, so based on electronegativity, this is the weakest because boron has the least electronegative. We know that this is the strongest of the strong, so that's going to be 5. And then it has, this is going to be right next to it, just a little bit weaker. So that's 4. This is the weakest because boron is less electronegative than chlorine or sulfur. We're going to call it 1. Now the battle is between these two. And so remembering that it's harder to take this hydrogen to come off, it's going to have a much lower Ka, and so this is going to be number 2, and then a little stronger than that would be 3. All right, so we're going to write them. H2BO3 followed by HSO3 minus followed by H2SO3 followed by HClO3 and HClO4. Okay, so points. 4, A is worth 4 and B is worth 4. So there was a point for mentioning each of those trends and a point for the explanations. But it was sort of like so they worded and they score better now, or it's a lot easier to see how they score. But you had to mention all 3 of those trends with an explanation of how the that bond was affected and the energy was different to break the bonds. Okay, so this was also worth 4 points, and the points were for so 1 point was for having these in that order, that correct order. 1 point, you could have reversed these. They didn't care which way you had it. But that was 1 point to make these the first. Because we don't really know. I mean, we don't have KAs or anything. So that was 1 point. And then 1 point was for making this correct. So that you had to have this charged one lower than the neutral one. And then the final point was for saying that both the SO3 was that both of the SO3s were weaker than the ClO3s. Why? Because sulfur is has a lower electronegativity than chlorine. Okay, so the fourth point was for having these two lower than these two. So that was 0.4. Okay, so see how many points you got. Okay, I should have said this at the very beginning of this video, and I did not, so I'm going to say it now. When you get to these, you need to try to work it, come back, and then watch me work it. But don't watch this and write down the answers. You've done no one any good. So you need to try it, and then you need to come back and see how many points you got. Okay, so if you didn't get very many points on this, I would not have blamed you because we haven't spent a lot of time on this in class. But these first two are getting you primed and ready. You should be able to do this forever and for sure for now. Okay.